Welcome to another webinars of our Deep Dive AI hosted by the Open Source Initiative. I'm Stefano Maffulli, I'm the Executive Director, and we're going to hear from Andreas Liesenfeld and Mark Dingemanse about opening up ChatGPT, a case study in operationalizing openness in AI. Hope you enjoy. We're going to take questions at the end.
Hi, my name is Andreas Liesenfeld and I am presenting joint work with Mark Dingemanse. So we work at the Center for Language Studies at Radboud University in the Netherlands, and today I'm going to talk about the Opening Up ChatGPT project, a case study in operationalizing openness in AI. So the idea grew out of a very practical concern that we had as academics based in Europe. In European academia, support for open source software is strong. In Germany, for example, open source software is set to become the norm in public institutions and a cornerstone of the country's digitalization strategy. In France, open source has been singled out as a critical component of scientific research in the recent open source policy. And in the Netherlands, the national digitalization strategy pushes an open source by default principle, urging public servants to use open source software wherever they can. So when large language models and text generators became more widely known through the release of ChatGPT, there was an urgent need to identify a technology of this type that is sufficiently open for use in science and education in Europe. So the starting question of the Opening Up ChatGPT project was, so we see all of this quote-unquote open source large language models cropping up, but how open are they really, and which one is the right pick for a use case that requires a maximally open and responsible technology? In our recently published paper, we present the results of a survey of openness in instruction-tuned text generators, and we released a crowdsourced live tracker to try to stay on top of this fast-moving field, where new supposedly open alternatives to ChatGPT were released almost every other day. So how do you survey openness in ChatGPT-like text generators? A first thing to note is that in complex AI systems, openness is never all or nothing. There are too many moving parts for a single openness judgment. Instead, we needed to break down the system into its parts. We decompose the system into its most relevant constituent elements and begin with a first broad division into three areas: the availability of code and data, the degree of documentation of the system, and options for user access. Then, within these areas, we further break down the system into its elements. For ChatGPT-like text generators, that includes at least these 14 features. While specific items on this non-exhaustive list might be up for debate or may depend on the specific configuration of the system, in any case, such a list should aim to cover all parts of text generators where evidence-based judgments about openness are feasible. Jumping straight to the results, if you take these 14 features and examine them one by one for each system, you get a large table like this. So currently this database contains information for around 25 systems, including ChatGPT itself, which ranks rather low for openness in comparison to similar available systems. Now, what I'll do is take two example systems from this large table and talk you through how they compare when it comes to openness. Both of them claim to be open source, but only one comes out on top of our ranking according to our evidence-based measures. The first is Bloom, an initiative supported by the French government. This is a project that brought together researchers from over 100 institutions for a year to create a very large language model. The other example in our comparison is a more recent model that also made headlines, Llama 2 by Meta. Meta itself introduced it as our open source large language model, and global media coverage almost without exception took over this qualification. As we will show, our method provides a way to form an evidence-based judgment on the truth and utility of this claim. Using Bloom and Llama 2 as an example, this is a walkthrough of the relevant dimensions of openness in these two systems. For Bloom, we specifically look at the instruction-tuned variant of the model called Bloom Z, And for Llama 2, we look at a family of 3 similar instruction-tuned models called Llama 2 7b, 13b, and 70b. We start with open code. In the classic sense of open source, we ask, is the source code of the model and training pipeline available? Can we inspect it? Can we look under the hood or perhaps even tinker with it? For Bloom, this is the case. For Llama, there is no source code available. No code is shared to reproduce either data curation, training, fine-tuning, or model evaluation steps. Hence, Llama 2 is flagged red for closed, and Bloom is green for open. Next up, we ask if the pre-training dataset, that is the dataset the base LLM is trained on, is documented and available. Again, Bloom receives a pass, while Llama 2 does not. Looking at the language model weights, we then ask whether the trained model is openly available. And we find that for Bloom, it's a pass, while for Llama 2, a registration step is required, and so that's a yellow, meaning partially open. Then we look at the reinforcement learning component of the system, and we ask whether the datasets used in the instruction tuning step are documented and available. We also ask whether instruction-tuned model weights are being made available. So in the case of this technology, this is the final product of the training pipeline that the end user would engage with. Then we look at the licenses the models are released under. So this is traditional OSI territory. So we use the existing OSI definition of open source to distinguish licenses. Llama comes with a community license by Meta, which is not OSI approved, and Bloom has 2 relevant licenses. The source code is Apache 2.0, which is OSI approved, but the model itself is released under the Responsible AI or RAIL license. Let's take a closer look at these licenses. The RAIL license doesn't count as open for OSI because it imposes limitations. But is unlimited always the best and most responsible way to release technology? The RAIL license is an interesting case of developers thinking seriously about responsibility and accountability. So for this technology that can cause actual harm, whose responsibility is it to prevent undesired uses? So particular use cases may be restricted, such as don't use the technology to exploit vulnerabilities of specific groups. And such limitations can help to prevent harmful applications, and both Bloom and Llama engage with such harmful use cases in their licenses. But how specifically is this responsibility to prevent harm being dealt with? So here are 2 quotes from the licenses. While Llama 2 states that you may not represent that Llama 2 outputs are human-generated, RAIL is much more restrictive and states that you may not generate content without expressly and intelligibly disclaiming that the text is machine-generated. So both organizations have chosen a different path to dealing with the responsibility to label model output. Now, back to comparison. Next, we look at the level of documentation of code. So this is not about whether or not data or code is available, but it is about whether the codebase is documented in sufficient detail. For Bloom, we have a full codebase, very well maintained and very deeply documented. Llama 2, on the other hand, shares only some minimal examples. Then we look at the documentation of the actual architecture of the system. This includes everything from hardware requirements to information how the model was trained, fine-tuned, or evaluated. For Bloom, this is all documented in great detail. For Llama 2, some elements are sketched in a corporate preprint. Speaking of preprints, another important dimension of openness is the extent of public scientific documentation of the system. We ask, is there a preprint providing scientific and comprehensive documentation of the system? We also look for peer-reviewed papers and find that they seem to have generally fallen out of fashion in this field. The next 2 items are about whether a model card and datasheet are available. Both of these are existing and standardized procedures that ensure relevant information about data and model design is made available. And lastly, we look at end-user access methods. and ask whether a software package is indexed and made available via a software repository. And we look at whether there is an API available with maximally unrestricted access. Now, a detailed comparison like this shows that while both systems claim to be open source, really only one is. And by drilling into the details, we can make the exact differences visible. Crucially, evidence-based judgments help to credit initiatives for care taken in developing and releasing such AI technology, but also to puncture corporate hype and to call out hijacking of terms such as open source. So after surveying around 25 of such text generators, we found that in many cases new systems either inherit data from existing ones or combine existing datasets in complicated ways, which makes it hard to delineate what dataset was used where, and which can lead to murky legal situations regarding the licenses and general use of datasets. We also found that synthetic data is on the rise, so that is data harvested from other large language models. Currently, around 40% of the systems we looked at use synthetic data in some form or another, with the legal and practical consequences still largely unknown. And another widely popular practice is release by blog post, where organizations share details about architecture and performance only via posts or preprints, often including insufficient detail. And peer-reviewed papers, on the other hand, are very rare. A more general feature of this type of technology is that these AI systems are complex and multi-part. They consist of multi-step training pipelines that commonly feature steps such as the training of a base model, then perhaps a fine-tuning step, and then possibly an RLHF component, such as in the case of ChatGPT type systems. And these long training pipelines pose a challenge when making a system as open as possible. So when it comes to tracing back these training steps or even reverse engineering such a system, later steps in the training pipeline can obstruct access to earlier parts. Crucially, true openness is here only possible if intermediate steps are documented and opened up. So true openness requires the supply of sources at each of such roadblocks in the training pipeline to preserve reverse engineerability to the greatest extent possible. To conclude, our approach to evaluating openness is to first isolate most relevant dimensions of openness in the respective system, then to provide evidence-based judgments on each dimension, and to do that work in public, open for contribution and scrutiny. A definition of any open generative AI system will need to define openness as composite and graded. There will be no one-size-fits-all solution, as domain knowledge will be needed to identify relevant dimensions of openness. Only this way, we believe, the spirit of reverse engineerability can be carried over to this new generation of technology. I thank you for your attention, and for questions and comments, please find our contact details on opening-up-chatgpt.io.